in module 13 we are going to talk about factoring, which is actually basically like a division of polynomials. So 13.1 is about finding the greatest common factor. All right, factoring by grouping and learn how to factor out the greatest common factor as well. So in this particular video here, I want to show you how to find the greatest common factor of a set of terms. So because after we learn how to find the greatest common factor, then we can begin to factor polynomials where we have to factor out the greatest common factor. So let's learn how to find the greatest common factor first. So this is something we learned back in module 1, which is using the prime factorization, okay, of all integers and integer coefficients. So once we're able to find the prime factorization, then we can list all the factors that are common to all the terms, including the variables. Raise each common factor to the smallest exponent on that factor in the list, then multiply these powers to find the greatest common factor. So let me demonstrate exactly what these 4 steps is saying. So I'm going to use this particular set of 3 integers. So I got 36, 30, and 42. I'm going to write this problem out, and let's see if we can figure out the greatest common factor just by looking at it here just in a minute. So 36, find the prime factorization of 36. Most of us know 36 is 6 times 6. So each 6 is made of the prime number 2 and 3. So another 6 has a prime number 2 and 3. So 36 is basically 2 times 2 times 3 times 3. So that's using prime factorization. 30. When we see 30 and think of what number multiplied is 30, normally we think about 5 times 6. All right, 6 is made out of 2 prime numbers, 2 and 3. 5 is already a prime number, so 30 is basically 2 times 3 times 5. All right, 42. What times what is 42? 6 times 7. So the 6 times 7, we know 6 is made out of 2 prime number 2 and 3, then times 7. So greatest common factor is basically find the common factor that is between all 3 terms or all the terms you have. So if we look at it, the factor 2 repeated between all 3 terms. So we count that as 1 time. All right, let's say another factor repeated between all 3 terms. Obviously, the 3 right here repeated between all 3 terms. So we count them as 1 time. Since there are no more factors that repeated between all 3 terms, then my greatest common factor will be 2 times 3, which is 6. So most of us kind of look at these 3 terms between 30, 36, and 42. Most of us know the greatest common factor is 6 because I have a factor of 6 in all 3 terms, and that's called the greatest common factor. All right. So let me do an example involving with variables so we can here I have 4x squared y squared, 2x y squared, and a 10x. So greatest common factor is about finding the repeated factor between all the terms. So let's look at 4x squared y squared. 4x squared y squared, the number 4 is made out of factor 2 times 2. Prime factor is 2 times 2. X squared means x times x. Y squared means y times y. All right, let's look at 2xy squared. 2xy squared. So the number 2 is a prime number, so let's just write down a 2. All right, x is just x. Y squared is actually made out of y times y. All right, so 2 times x times y is a breakdown of this term, 2xy squared. 10x squared. 10 is made out of prime number 2 times 5. X squared is x times x. All right, so the factors of 10x squared can be rewritten as 2 times 5 times x. So greatest common factor, remember, greatest common factor is looking for the repeated factor between all the terms. So I see my factor 2 repeated between all 3 terms, so we count them as one time. All right. This 2 did not repeat, so cannot count it. 5 did not repeat with other terms, so cannot count it. Let's count x. X repeated between all 3 terms, so we count that as one time. All right. Since the second term don't have any more x, so there's no more x repeated between all 3 terms. Since the third term does not have a y, that means y, the variable y, did not repeat between all 3 terms. So my greatest common factor would just be 2x. So let me kind of type this out for us, and we can make a conclusion. So what exactly is a greatest common factor? Is actually the largest factor that repeated between all the terms. Okay. So for variables, when it comes to variables, thinking about the same thing, repeated between all the terms. So for variables, we're always going to choose the smallest exponent. All right, why do I have to choose the smallest exponent? Because, think about it, when I look at these 3 terms, all right, between 4 to 10, I know factor 2 is in all 3 terms. That's why I have a greatest common factor 2. If you look at the variable, x squared, x to the first, x squared. So by counting repeated factor, there's only one x repeated between all 3 terms. Okay, so that's why the greatest common factor is 2x. So that's why we always have to choose the smallest exponent, because the smallest exponent will repeat between all the terms. Now, why don't I pick any y? Because the first term has y squared, second term has y squared, but the third term does not have a variable y. It actually does. It's actually y to the 0 power. So by choosing the smallest exponent, y to the 0 power is actually equivalent to 1. That's why I didn't write anything about y to the 0 power. So just by looking at it, make sure the variable repeat between all the terms. If it does, then we choose the smallest exponent. Okay. Most of the time, for the greatest common factor of the numerical value, we can look at it and we can tell what the greatest common factor is. Okay, because most of these are thinking about multiplication table. It's very important that we know the greatest common factor, because when it comes to factoring polynomial, where we got to factor our greatest common factor, if we don't see the greatest common factor, or if we cannot find it, then our polynomial is not factored completely. So be very careful as we go along in module 13. All right, so this is going to be a quick lecture video on how to find the greatest common factor. Thank you for watching.